we are in electromagnetic induction chapter, right? So in the previous class, okay, for you, Hari, it will be some other chapter going on that day, isn't it? That day I think I was teaching moving charge and magnetism for you, and suddenly you have shifted to this batch. This is the final batch. I hope it does not change further. And in your school, what is going on now? Oh, volume 1 is fully completed. Then I think it will be not much difficult for you to score up in today's class. But whatever it may be, let us not worry about that. So in the previous class, we have finished half part of electromagnetic induction, and today we are going to complete the whole chapter. So today we are going to learn and complete electromagnetic induction. Okay, let me recall quickly whatever we have seen in the previous class. Okay, so in the previous class, which happened last Wednesday, and also yesterday I took same EMI class, what I taught you about, first thing was magnetic flux. Magnetic flux is the dot product of magnetic field and area vector. Mathematically, phi is equal to BA cos theta, where B is the magnetic field, A is the area vector, theta is the angle made between magnetic field and area vector. So if you have an area, and on this area if you have magnetic field passing like this, don't think that theta is 90 degree, theta is 0 degree, because area vector is perpendicular to the area, and if this is magnetic field direction, then between them angle is 0 degrees. Be very clear in that. So the formula of flux mathematically is given by the formula phi is equal to BA cos theta. Then we learnt the Faraday's experiments, where he understood what is the cause of induced EMF. He found that whenever there is a change in magnetic flux, there is an induced EMF, and if the circuit is a closed circuit, there will be induced current also. He also told that this induced EMF will last only till there is a change in magnetic flux. If there is no change in magnetic flux, then there is no induced EMF. If there is a big change in magnetic flux, there will be a big induced EMF, or I should say that induced EMF lasts only till there is a change in magnetic flux. Very important point. This was the first law of electromagnetic induction, given by whom? Given by Faraday. Then came the second law. The second law is the magnitude of induced EMF, which is always equal to rate of change of magnetic flux. So magnitude of induced EMF is always equal to rate of change of magnetic flux, is the second law of electromagnetic induction, which is E is equal to d phi by dt. After which we learnt Lenz's law. Lenz's law states that direction of induced EMF will be in such a way that it will oppose the cause of it. And we spent a good amount of time in the last class, even yesterday when I took it, over learning how the questions from Lenz's law is coming. They will give you a condition where you have to identify whether magnetic flux is changing or not. If magnetic flux is not changing, no induced current. If magnetic flux is changing, you have to identify whether the magnetic flux is increasing or decreasing. If it is increasing, you have to put direction of induced current in such a way that it should reduce it. If it is reducing, you have to put the direction of induced current in such a way that it has to increase it. It sounds complicated, but it is very simple if you understand the logic. So before I start my today's class, once again a question. This question is for Kirti, if you are hearing me. Last class you not answered this, so now I am asking you once again. Think and say. If you are wrong, I will correct you, no problem in that. Okay? Unmute yourself and tell me, if this magnet is trying to pass through this coil and come down. So magnet has passed the coil and coming down. Okay? I hope you are understanding the question. There is a coil and the magnet is passing through it and coming down. Will there be any induced current in the coil or not? If there is induced current in the coil, what is the direction of induced current? Make it fast.
When it passes through, there will be an induced current in clockwise direction.
In the clockwise direction. Why is it so?
Because the north pole is facing it.
So north pole is actually anti-clockwise, no? So what is the answer? Anti-clockwise? You should say step by step, then only it will be clear to you. You told very correctly that magnetic flux is changing, so induced current will be there. Now the identification of direction of induced current is only the challenge. Think for a while. Dishita, you want to try this first? Dishita, if you are hearing me, unmute yourself.
Yes, sir.
Yeah. First of all, I itself told that magnetic flux is changing. Can you tell me, Dishita, whether the magnetic flux is increasing or decreasing? Think and say. You cannot see anything and say. You should think here and say whether the magnetic flux is increasing or decreasing in this case. Try. This much time if you are taking, you will tell me fast.
Is it decreasing?
Obviously decreasing. If it is entering, it will be increasing. It is exiting, right? So it is decreasing. Correct. So induced EMF or induced current will try to increase it. Right, Dishita?
Yes,
How it can increase it? Think for a while. Krishna Raghavan, unmute yourself. Yeah.
Yes, sir.
What is the answer for this question?
Sir, magnetic flux is reducing, sir.
Very good.
And
Induced current will try to.
the clockwise
Sir.
direction.
Why clockwise direction, Krishna?
Sir, the south pole is moving away from it, sir.
Yes, very good. So it wants to become.
English EMF will try to increase south.
No. Wrong. Akhilesh, give a try. Yes, 1 second. Yes, Dishita, tell me. Wait, Akhilesh.
Sir,
Haan.
so induced EMF is decreasing. We should put the direction of the current so that it increases.
Okay, so what is the direction of current to increase it?
So clockwise.
Why clockwise will increase it?
Uh,
Please guys, again I am repeating, until your concept is crystal clear, you will make mistakes in questions of Lenz's law. Yesterday same thing I was saying. You should have full clarity, you cannot mug up this law. I will come back to you, Dishita. Yes, Sai Akhilesh, I gave a chance to you.
Sir,
Yes.
the current is magnet increasing, sir, so it will try to increase it, sir.
Okay.
So to attract the magnet back, it will become north pole, sir, so it will be anti-clockwise, sir.
Very good.
After it will be clockwise, sir.
Yes. Very good. Correctly he told step by step. When the magnetic field is trying to reduce, the induced current will try to increase it. If it wants to increase it, it should pull back the magnet, try to pull back the magnet at least. So if it wants to pull back the magnet, it must become north pole down, and to become north pole down, it must flow current in the anti-clockwise direction from the down. Why I am mentioning down? Because anti-clockwise position from down will become clockwise from up, isn't it? If I am rotating like this, anti-clockwise, somebody seeing from up, now it will look clockwise to them. Like how it is happening. For me, anti-clockwise, for you it is clockwise, isn't it? Same way. So it is very important to mention anti-clockwise from down. I hope you get my point. Already I have spent a lot of time in this. So one more question I would like to give to Vigneshwaran. Will you try? Yes or no, man, give a try. You were there in last class, right? Have you learned Lenz's law from me? Do you remember Lenz's law? This much doubtful you are means don't try, leave it. Akshay, I will try. Please try. Right along is secondary, okay? I have a coil which is moving from here and trying to go outside the magnetic field. Whether induced current will come in this coil or not. Yeah. Why it will come? Changes. It's increasing or decreasing? Decreasing. Very good. So it will. Very good. To increase it, what that should be of current? Why?
Because
Yes.
So to increase it, it will go out of the plane.
If it goes out of the plane, it will reduce it, no yaar. You are telling everything correctly. To increase it, it should go into the plane only, no magnetic field. And to make into the plane,
Clock.
clockwise, yaar. Clockwise only will produce into the plane. Anti-clockwise will produce out of the plane. Your concept was clear, but you confused in whether clockwise is into the plane or anti-clockwise into the plane. These things should be very, very, very calmly dealt. Shaktivel, if your video can be on, I would like to hear from you. Shall I give a question to you, Mr. Shaktivel?
Right, sir.
There is a coil trying to enter the magnetic field. Explain me whether any induced current will be there or not. If yes, direction of induced current. Fast. You revise whatever I have taught. Meanwhile, Navina, unmute yourself. Try to answer this question. Try.
Sir, as it is coming towards the magnetic field,
Yes.
I think there will be an induced EMF created.
Very good. Because magnetic field is changing. Yes.
Yes,
Is it increasing or decreasing?
it is decreasing, sir.
I think and say, Navina, it is entering the magnetic field. So how decreasing? There,
Sorry, sir.
there is no magnetic field, little bit more, very much more. It is increasing, right?
Yes, sir.
Okay, then induced current will try to,
Just a second, sir.
yeah, you take 5 minutes itself. Yes, Devadarshan, give a try fast.
Sir, it will produce EMF because it is entering into the magnetic field. So there will be an increase in it, and it is into the side, the direction is anti-clockwise.
So anti-clockwise direction of current will try to reduce it. So to reduce it, it must produce the current in the anti-clockwise direction, because anti-clockwise direction means out of the plane magnetic field, and out of the plane magnetic field will reduce into the plane magnetic field. Shall I ask a question to you now? Question is for Mrityunjay from Tiano Vidyashram. Will you try? Huh? Palm Suraj just now came. Let him cool down. Yeah. Now only ran and came, if he ran and came. Okay. Shall I? No. You will try, Yashwant? See, he has the courage of trying at least. Get that first. Yes, Yashwant. This magnet is trying to go away from the coil. Very good. Wait. Don't be in a hurry to answer. Magnetic field is decreasing is very correct. So induced current will come is also very correct. Induced current will be in such a way that it tries to opposes what is the cause here? Current is not decreasing. The magnetic field is decreasing. Magnetic field is decreasing. Induced current will try to who told it oppose? Step by step. Okay, Yashwant? When the magnet is going away from the coil, magnetic field is decreasing. Correct. If magnetic field is decreasing, induced current will try to increase it. To increase it, it must pull it back. It should become a south pole. To become a south pole, direction of current should be very good. Clockwise, Thambi. South pole is clockwise. North pole is anti-clockwise. Dealing with aliens only. Anti-clockwise is north. Clockwise is south. Your way of thinking is correct. Good, I appreciate that. But you are not knowing that south pole is clockwise and north pole is anti-clockwise itself is not correct. Okay? Good try. I will not take further questions because I will get stuck here itself for 1 hour. So this is what is Lenz's law, where the questions will come very similar to whatever I have asked you. They will try to move a magnet They will try to move the coil into the magnetic field, out of the magnetic field, increasing, decreasing, anything they may give you, anything they may give you. And they may expect you to find the direction of induced current. And direction of induced current can be told by you correctly only if you are using that algorithm. What algorithm? Checking whether magnetic flux is increasing or not. Not increasing, induced current 0. Increasing, checking whether it is increase in magnetic field or decrease in magnetic field. Increase in magnetic field, checking whether it is increase in into the plane or out of the plane. Decreasing, checking whether it is decrease in into the plane or out of the plane. Then putting the direction of induced current in such a way that if it is increasing, to decrease it. If it is increasing into the plane, you will put direction of current to produce out of the plane. If it is increasing out of the plane, put direction of current to make it into the plane. If it is decreasing, two possibilities, decreasing into the plane, decreasing out of the plane. If decreasing into the plane, you will put direction to make it into the plane. If decreasing out of the plane, put direction is going to make it out of the plane. Whatever I told now, it looks very complicated to listen, to hear, but it is very, very, very simple process. And I believe me, you cannot escape from this. If you are thinking, I will leave this topic itself. One thing, you are fool, you are leaving this topic, simple topic. Next thing is, you will miss marks in the board examination. Total mark will not remain 70 for you, it will become 65 or 64. Whatever, coming back. Now, I will give a question to everybody of you. Try this question. There is a magnetic field. What is the magnetic field? This question is, in this magnetic field, I am keeping a coil. The magnetic field is a varying magnetic field. It is a varying magnetic field given by the equation B is equal to B naught into T square. Magnetic field is fluctuating by the equation B is equal to B naught into T square. Determine, the question is determine three things. First is induced EMF. Second is induced current. Third is total charge from t is equal to 0 to t is equal to t naught seconds. This question has come in the board examination. This question has come in the board examination in past. They gave there is a coil of resistance R. Coil of resistance R. Make it fast. Whatever you know, you try. Right or wrong is secondary. Whatever you know, you give a try. Don't worry about being right or wrong. Small r is the radius of the coil. If you want to take it as r. Shall I solve this question? Will not solve. Solved. What doubt? Tell me. Hmm. You are not putting A cos theta and all these things. EMF will become equal to minus d phi by dt. Forgot Karthikeya Balan? I'll do, you just check yourself. Okay? So E will become equal to minus d by dt of this phi. Phi you have taken as B actually. What? Karthikeya Balan? You took phi as B. That's the mistake you did. So phi will become equal to B into A into cos 90. No, cos 0. Why cos 0? Because area and magnetic field are parallel to each other. So you are going to get E is equal to, what is d by dt of A will come outside, let it be A itself, A, negative A, d by dt of B, what is B given as? B naught into T square, isn't it? So what will be EMF then? Minus A into B naught into 2T, am I right? Any problem? This is the value of EMF, minus 2 B naught A into T. And from where to where they asked? From T is equal to 0 to T naught. So maximum value you will put T naught here. If you want, write pi r square, your wish. If somebody is writing pi r square into B naught into 2 T naught, they are also correct. Nothing wrong in that. For? Yeah, I'll come to that, yes. Then comes, after finding EMF, we have to find current. Current is very simple because current will become equal to EMF by resistance, Ohm's law. So what is EMF given? Minus A into B naught into 2 T naught by R is the answer, over. Current can be indicating that it is produced in the opposite direction. V is equal to? Yes. Or if you want, see, one more way of understanding is there. If you see here, area vector is in this direction and into the plane magnetic field, cos 180 is minus 1, it will become plus. It's just the direction game here. It's not something which is very much important. But see here, now the third is very important, total charge, because charge will become I is equal to dq by dt. So dq will become equal to I dt. And here you will put the limits of integration. Integration both sides you will get q is equal to, from where to where? T is equal to 0 to T is equal to T naught into I dt. What is I? I we have found here. A, negative A, B naught into 2 T naught by R into dt. Actually I should not put T naught here, I should put T only. At last only I should put T naught. T naught is for the last value, isn't extreme value. So if I put that, then here the integration of T dt will be how much? Negative A, B naught, 2 will come outside by R will come outside. What is integration of T dt? T square by 2. Limit from where to where? 0 to T naught. So this 2 will cancel this 2. Q will become equal to negative A B naught into T naught square by R. Got it? The value of EMF, the value of current and the value of charge. So what you are learning from here is, when you differentiate magnetic flux, you get induced EMF. If you divide induced EMF by resistance, you get induced current. And when you use I is equal to dq by dt, you will get the value of charge. Now see, this is not taught in this chapter, it comes from your current chapter of third chapter itself. So nowhere you have learned this now, but you know this basic thing, I is equal to dq by dt is not new for you. And this is how the questions are being kept in the examinations. So I hope there is no doubt in this. If you have any doubt, please ask me. If it is clear, I'll go to the next concept. Tell me fast. Is there any doubt? No? Can I go to the next concept? Shall I? If you allow me, I'll change the page. Shall I change the page? Okay. Next concept, please note it down. Next topic in this chapter is motional EMF. In some schools, they will say it is out of the portion, they are not teaching, but I will teach motional EMF because there are questions in NCERT book from this topic. Without that, you cannot solve those questions. So I don't know how some schools are claiming that motional EMF is not there in syllabus. In your school, they taught motional EMF? Teaching, right? Yes, so it is there only. If some school is saying not there, don't confuse yourself. It is to be learned only, motional EMF. Okay, let me make you understand what is the meaning of motional EMF. So, suppose you have a magnetic field here. What is this magnetic field? Into the plane, am I right? When I taught to you in the last class about the electromagnetic induction concept, I said to you, whenever there is a change in magnetic flux, there is an induced EMF. If the coil is a closed coil, we have induced current also. You will realize now, if I take a conductor, a conducting rod if I take, keep in magnetic field, no current, nothing is there. I am just moving this conductor from left towards right. You know what will happen? It will have EMF generated across its end. It means this will behave equivalent to a battery like this. So a rod, just a rod, conducting rod, moving in a magnetic field behaves like a source of EMF. Concept of this, why it happens, let us learn now. First, you understand what we are going to learn. Did you understand what we are going to learn now? I am going to explain you how a conductor moving in a magnetic field becomes a source of EMF. That is, behaves like a battery. How? Yeah, tell me, Sharan Ram.
Sir, are we moving this conductor from inside a magnetic field to outside or just
No, into the magnetic field only, not outside or is thing.
how is that changed?
Let us learn that. I am going to teach now. Pay attention. Yes.
Current is flowing in the rod.
No, nothing. Just a rod, no current. Just a conducting rod. If you move in the magnetic field, I say that it gets a EMF across its end. The moment it gets EMF, it means it becomes a source of EMF. Source of EMF means like a battery. Like a battery. We are going to understand now how this happens. Concept level, please pay attention. It is not there in the book also. So when this conducting rod is moving from left towards right, what is taking place? Let us try to understand that. I am drawing a magnified diagram of this. So magnified, if I see this rod, which was trying to move in what kind of magnetic field? Into the plane magnetic field. So if it is a conducting rod, it has free charged particles. I have always told this to you. A conducting rod, a conductor, a metal has free charged particles. When I say free charged particles, it includes both negative and positively charged particles. So imagine there is a negatively charged particle which also moves towards the right because the conducting rod is moving. There is a rod here, it has electron. If rod itself is moving, the charge also is moving. It means what? There is a current produced in the opposite direction, right? You know very well, if electron moves towards right, current will come towards left. So the movement of electron towards the right is creating current towards the left, and there is a magnetic field. If I use Fleming's left hand rule, I will get direction of the force. So magnetic field into the plane, current direction opposite, that is in the towards the left, my thumb is pointing downwards. This electron is subjected to a force downwards. What will happen? It will go and accumulate down. The same will happen with other electrons also. So, electrons starts to accumulate down. What happens to a positive charge? Positive charge movement creates current in the same direction. If proton move like this, current will come in the same direction. So, now put left hand rule, magnetic field into the plane, current towards right, force acting in the upward direction. So, positive charges will be deflected upwards. Do you agree with me? Do you agree with me? What I am coming to tell you is that all the negative charge starts accumulating downward and all the positive charge start accumulating upward. Why it is happening? It is happening because of magnetic Lorentz force, QVB sin theta. Remember this, F is equal to QVB sin theta. Whenever a moving charge is placed inside a magnetic field, it experiences a force. Charge is there, charge is moving also, magnetic field also is there, it will experience a force and that force will make the charge to move either upward or downward. Positive charge goes upward and negative charge goes downward. Exactly ulta would have happened if the magnetic field would have been out of the plane. If magnetic field would have been out of the plane, negative would have gone upwards and positive would have come downwards. Now, accumulation of positive and negative charge, don't you think that it will create electric field here? Don't you think so? Common sense, there is positive charge, there is too much of positive charge here, there is too much of negative charge here. What will happen? It will create some electric field. From where to where? Positive to negative. Earlier, I had only magnetic field. Now, what I have additionally? I have electric field also. And how this electric field comes? It comes because of accumulation of positive charge and negative charge towards upside and downside of the rod. Okay, what it does you see? If there is a electric field being created, the positive charge which was trying to go upwards because of the magnetic field, now will try to go downwards because of the electric field. A positive charge was deflected where? Upwards. Electric field created. You know very well, electric field, positive charge moves in the same direction of electric field, isn't it? So, this positive charge now will experience a force downwards because of electric field. Initially, it will be less because less accumulation of charge, less electric field, dominating magnetic field, it will not be able to go down, it will go up only. But with time, accumulation of more positive and negative charge will create a stronger electric field. A point will come when the force on a positive charge, force acting downwards by electric field and the force acting upwards by magnetic field becomes equal. That is called as equilibrium condition, and after which no further charge will travel upwards or downwards, because now the force acting on it upward and downward is same, it won't move. I hope you get my point. So, now positive charge, negative charge, what is it looking like? A battery. What is there in battery? Positive end, negative end, right? That is why I told a moving rod in magnetic field behaves equivalent to a battery. And one more thing, mathematically if I solve it, mathematically this happens when? At equilibrium. So, at equilibrium magnetic field is equal to electric field. What is magnetic field value? Q V B. Sin theta sin 90 here. What is electric field? Q E. First chapter, Q into E gives force. Q gets cancelled. What are you getting? VB is equal to E. What is electric field? What is electric field? with respect to potential. You know, electric field is equal to electric potential by distance. Remember this. So if the rod has a length of L, don't you think that electric field can be replaced by VB will become equal to V by L? V is a kind of potential. I can also represent by EMF. E. Not electric field here, this E is the EMF, okay? Don't think it is electric field, EMF, voltage. From here I get a new formula. EMF is equal to B L V. This EMF has a name, it is called as motional EMF. Why? Because it is coming due to the motion of the conductor in the magnetic field. That's why it is called as motional EMF. And this motional EMF makes a conducting rod to act as a source of EMF. It means that if I am having a magnetic field here and if I am having a rod, conducting rod here, I connect one wire here, another wire here, one light here. And just because I move this rod, no, bulb will glow. Static, it will not glow. Because motional EMF is BLV. Velocity is 0, EMF is 0. Magnetic field is switched off, no EMF. Length cannot be 0. So if velocity and magnetic field exists, only then the motional EMF will come into picture. I hope you are getting my point. If I am having a rod which is moving in the magnetic field, and if I connect one wire, a bulb, just by moving my rod right and left, I will be able to glow the bulb. Why the bulb is glowing, you are understanding? Because of the motional EMF coming across the ends of the rod, and how much is its value? BLV. So motional EMF formula is BLV, where B is the magnetic field, L is its length, and V is its velocity. If you have understood this, copy it up first. Whatever I have told the theory here, you cannot write, but you will forget tomorrow, I know. So write something by your own. Yeah. Very feeble magnetic EMF will come, man. You can do, man, but for setup, know how much money you will require. For it, you will produce a current by some other method itself. So these things are application. We can use it. We are using it actually. I'll tell you how we are using it also. Move what? Obviously, some force is required. Is only converted into electrical energy. Conservation of energy is valid only. Obviously valid. How it will be invalid? Then law of thermodynamics will break. If that happens, then second law of thermodynamics is invalid.
Sir, then heat will come, sir.
Yeah, energy will be lost also. It will not move by itself, right? How rod can move by itself, man? You need to appoint somebody to move the rod left, right, left, right. That force that you are applying is becoming work in becoming energy, and that energy only is getting converted into electrical energy. I will give a question based upon this now. If you have understood the concept, just write short notes based upon what you have understood. If you want to ask something to me, feel free to ask. Because I am 100% sure tomorrow you will forget whatever I have told now. Anshul, why is your video getting off?
Not sure, sir.
Quite a few times your video is getting off, man, today.
I will check it, sir.
You will check it, or shall I check it with your mom?
Sure, sir.
Tell me, College 11.
Sir, due to the magnetic Lorentz force, the positive charge goes up and the negative charge comes down, right, sir?
Yes, correct.
After that, could you explain again, sir?
I said that since the positive charge is going up and a negative charge coming down, it is creating a source of electric field, because positive charge, negative charge will create electric field. This electric field will give a force on the charge once again, because a charge kept in electric field will experience a force, and that force is given by Q into E. So a time will come when the electric field and the magnetic field becomes equal at equilibrium, and this point only QEV will become equal to QE, and when we solve we get the value of motional EMF as BLV. Got it?
Okay, sir. Thank you, sir.
Have you copied, guys? Tell me, Yuvashri.
So can you explain why the negative charge is moving downwards and positive is moving upwards?
See, I'll explain to you. When when the conductor is moving from left towards right, then the positive charge and negative charge also move from left towards right. So if positive charge is moving towards right, current will come in the same direction. So current direction is towards right and magnetic field is into the plane, the force will act towards upward direction. That's why the positive charge gets deflected upwards. When a negative charge is moving towards right, negative charge is creating current in the opposite direction and magnetic field is into the plane. So thumb will go downwards, it means negative charge will go downwards. So negative charge accumulates downward because of magnetic force and positive charge accumulates upward because of magnetic force. I hope it is clear. Yes. Shall I give a question then now? A question which came in the board examination for 5 mark. 5 mark it came. Don't think EMI is a small chapter, they will not ask question from here. A 5 mark question from EMI. Take the question. Question is, first let me give you some simple question to make you feel a little confident. The question is like this, simple question this is. This is not 5 mark, okay? This is a simple question, maybe 2 mark question. So there is a magnetic field which is into the plane and there is one rail here, another rail here. You know what is the meaning of rail, right? Anything can move on it, that's what is called as a rail. And here we have a resistance, 2 rails and 1 resistance. Its value is given as 10 ohm. There is a moving rod. This rod is what? Moving rod. It is moving towards right with a velocity of 5 meter per second. Magnetic field in the region has a value of 0.5 Tesla. They are asking what is the current in the wire. This is the question. Magnetic field is, good question. Length of the wire is 2 meter. Wire means this rod is 2 meter. Yeah.
0.5 ampere, sir.
Yes, you are right, Akhilesh.
Yes, 0.5.
0.5 is correct. Common sense. BLV by R. B is 0.5, L is 2, V is 5, R is 10. So 0.5 into 2 into 5, which will become 5, by 10 will become 0.5. Without even taking a pen, you can say the answer. Simple question, isn't it? Current is EMF by resistance. EMF is BLV. B is given as 0.5, L is given as 2, V is given as 5. 0.5 times 2 times 5 will give you 5, divided by resistance, which is 10. 5 by 10 will give you 0.5. You solved, no, by pen. Yeah, very good. Simple question, right? Anybody has doubt in this question? I don't think you should have. Suraj? Not sleeping, no? Next question. This question you solve. Good question. Shall I give? Diagram is very similar. There is into the plane magnetic field. There is rail. There is resistor. Resistance is given as R. There is a moving conductor having velocity V naught. One more thing they have told, the resistance of this rod is small r, okay? Resistance is small r, okay? Magnetic field is given as B. Question is, there are three parts. The first part of the question is, find motional EMF and current. Simple question. 1 mark. Find motional EMF and current. Second question. Second part I mean. 2 mark question. Find the force required to keep the rod moving with constant velocity. And third part, once again 2 mark, find input and output power. 5 mark question. All of you will solve first part, so that's why it is 1 mark. Second part and third part are carrying 2 mark. Yes, Mr. Sharan Ram.
Sir, any information about the length of the wire?
Take it as L, nothing is given. L is the length of the wire. Now solve. Rod has a length of L. Resistance connected externally is of capital R value. Resistance of the conducting rod is small r. And magnetic field is B, its velocity is V naught. That's all is given. And they're asking you to find the motional EMF. I think everybody will say the answer. It is B, L, V naught. Current, all of you will say B, L, V naught divided by R plus R. If you don't write just R, because there are two resistances here, external and internal. So R plus R. I told the answer for the first part. Second part, third part, you solve. If you are not able to solve, I will help you, but you try for at least for 2-3 minutes. Make it fast. Next topic is also there. Inductance, self and mutual inductance. Yeah, tell me what. Input or output? Output current, how much you telling? Output power, how much you telling? B, no, mistake.
Sir, this force is PV.
Force is how much? Tell me again.
PV.
B into V.
Yes, sir.
No mistake is there in that. Check your answer once again. BV square? Still wrong.
Sir,
Tell me again. Tell me when.
sir, F equal to the expression is V square L square V by R, sir.
B square L square V by
R.
R plus R, no man.
Yes, sir.
That is correct. Force, what is? Force will be B square L square V by R plus R. That is correct answer. Good.
Yes, sir.
Yeah. I'll solve it, man. Don't worry. I'll solve it. You try. Waiting for me to solve? Shall I solve it? Shall I solve it? Huh. Try. Got it, no? I'll also solve it now for everybody else. So I gave the answer for the first part of the question already. Once again I am repeating. Wow, Yashwant Kumar coming at 8:15 p.m. Great, man. E is equal to BLV, which will become equal to B into L into V naught. And what will be current? Current will be EMF by resistance. In this case, R plus R. So current value will become equal to B into L into V naught by R plus R. If you write these two things, 1 mark will be given to you. Don't worry about that. Okay. Then comes the second part. Second question, the second part of this question is asking you, find the force required to keep the rod moving with constant velocity. Now please pay attention. Very conceptual thing this is. Answer you may get also, but the concept, is it clear? Let us check it now. So what is going to happen? The moment we are moving this rod towards right hand side, you understood that there is an EMF going to come and this EMF is going to create a current in the rod. Did you bother to find direction of current? You should find magnetic field into the plane. Current we can find by using right hand rule. I am using left, sorry. Induced current direction, right. Magnetic field into the plane. What we are finding? Direction of induced current, sorry, yeah. So direction of force is what? Force is towards right. So magnetic field and force is towards the right, isn't it? So which direction the induced current is acting? no, BLV, motional EMF, current we found. Direction of current we can find by more different way, which is actually by understanding whether it is going to give plus above minus below or minus above plus below. That is only correct way actually. Okay, fine. So if the rod is moving towards right, just now we did the same question, derivation. We came to know the positive will go above, negative will come down. So what is the direction of current going to be? Positive. So it will become like positive, negative, isn't it? So current will be going like this now, this direction. Current direction, guys. This will behave like plus minus, isn't it? So how the current goes from positive to negative? The current will flow like this. I hope you are understanding what I am trying to say. Now I have got direction of current. I have direction of magnetic field. By using left hand rule, I can find direction of force. So magnetic field is into the plane, current going upward direction. There will be a force acting in the left hand side. Do you agree with me? And how much is the force going to act? The force due to current carrying conductor kept in magnetic field, ILB sin theta, remember? So I is the current, L is the length, B is the magnetic field. So I am going to get the value as ILB. Theta is 90 degree here, ILB. In this case, we have found what is the value of I. What is the value of I? I value is BL V naught by R plus R into L into B. What is the answer then? B square L square V naught by R plus R. What is this? This is the value of force. This is not the answer, by the way. This is the force that is going to act in the opposite direction of the force that you are applying. Now this force will make the rod slower. The rod was trying to move towards right. Because of the force acting on the wire, it is getting a force in left direction. What is the meaning of that? It is deaccelerating it. It is trying to stop it. What is the question asking to you? Find the force required to keep the rod moving with a constant velocity. It means what? The same force you will apply in this direction to make sure that these two are cancelling each other and the rod keeps on moving with the same velocity, right? This is the concept. Answer is same. But the concept says that what value of force you have found is not the force you are going to apply. This is the force coming on the current carrying conductor kept in the magnetic field. Any current carrying conductor kept in the magnetic field will experience a force of ILB sin theta. And that force is acting in such a way that this rod velocity is reducing. If you want to make sure that rod velocity does not reduce, what you will do? Apply the same force in the opposite direction. These two forces will cancel each other and the rod continues to move with the same velocity. So the answer is B square L square V naught by R plus R. But the concept is this. Is it clear to everybody? Next, third part of the question. Third part of the question is find, I erase that, find the input and output power. Input and output power you have to find. Now, what is input and what is output power? Power formula is what? Force into velocity. So, force value we already have, velocity value already we have. This will give us the force which is input. So, input power will become equal to force into velocity, which will become equal to force is how much? B square L square V naught square by R plus R. How do you find the output power? Which will be produced by the current. How much will be that? I square R, you forgot the formula. Power is equal to I square R. Don't know this formula. P is equal to VI or P can be written as I square R. I hope you remember this. Small I am writing. Yeah. So I square R. What is I? I is that B L V naught by R plus R whole square into R. R is what? R plus R. Isn't it? What are you going to get? Going to get the same thing, which is power output will also become equal to B square L square V naught square by R plus R. Obviously, it will be same. Input power is equal to output power. Is the question clear? Again, it is not a tough question. If you understand the question, it is simple only. Any doubt in this question, ask me. Or I will start talking next topic. Today I am planning to finish a chapter. What remains now is mutual and self inductance. I will talk about that. Is it clear to you whatever I have taught now? Whatever I have taught now, is it clear to you? Any problem? Shall I go to the next concept? Shall I go to the next concept, guys? I will give 1 minute time to copy. If somebody is copying something, take 1 minute of time and copy it fast. Done. Let me know if you are done and give the heading as self and mutual inductance if you are done. Self and mutual inductance. Can I proceed? Everybody online? Shall I proceed, guys?
Yes, sir.
Okay. Next topic in this chapter is self and mutual induction. With this topic, we will wind off this chapter and slowly enter the 7th chapter, alternating current. AC generator is not there in syllabus, which I have taught actually to you in the last class where we derived E is equal to E naught sin omega t. What was that? That only. Last class I told you, no, E is equal to E naught sin omega t. Whenever you are rotating a coil in the magnetic field, there is an induced current, and that we found. Okay. Anyhow, today we are going to talk about self and mutual induction. Please pay attention. Please pay attention. Okay. Imagine I have a coil. You can assume like solenoid, and I am having a battery here and a key here. When I switch on the key, what will happen? Current starts flowing inside. Initially current is how much? 0. The moment you press the battery, press the key, it starts to increase its current. If suppose the current is going to be 2 ampere, then 2 ampere it will reach. But from where it went to 2 ampere? 0. So initially 0, then it became 2. But then 2 ampere will not change because current will not change in the coil. Why it will change? Until you change it intentionally. When I off it, what will happen? 0, from maximum to 0. If I keep on pressing off on, off on, off on, off on, what will happen? 0, maximum, 0, maximum, 0, maximum. current is changing, and current inside a coil produces magnetic field. Remember how much magnetic field? Mu naught Ni, last chapter. Remember this formula? Solenoid's magnetic field, mu naught Ni. So whenever I am going to change or on the battery or off the battery, there is going to be a current change which will create a magnetic field change, which will create a magnetic flux change, which will create induced EMF. This induced EMF is, this principle overall is called as self-induction. Self-induction is when the induced EMF is produced in the same coil where there is a change in magnetic flux. That kind of induction is called as self-induction. Right? That self-induction is the induced current coming in the same coil or induced EMF coming in the same coil where there is a change in magnetic flux. Induced EMF coming in the same coil where there is a change in magnetic flux. Where there is a change in magnetic flux. Okay. Now pay attention. This topic I have taught in that one day night of 11 o'clock class. The same concept I have taught that day. Where Shweta Shinde you left before 15 minutes. Everything I am noting here. Okay, fine. Okay, keep it. What is it? Okay. Now please pay attention. Now what I have done? I have taken a circuit with a coil and a battery and a key, and another coil with just a galvanometer. When I on the switch, current goes from 0 to maximum, magnetic field goes from 0 to maximum, magnetic flux goes from 0 to maximum, and there is a induced EMF. But now what is going to happen? Whatever magnetic field is produced, that magnetic field will link with this coil also. You may think how? Magnetic field not produced only here, right? It is produced like this around it. So some magnetic field will link with this coil also. If you are confusing in this, imagine like this. One coil, another coil. Possible, right? I have overlapped them. So one coil like this, one coil like this. Are you feeling that? So now whatever I do a change in the primary coil, that change will affect the secondary coil also. In secondary coil, I don't have any source of EMF. This coil is called as primary coil. This is called as secondary coil. So whenever there is a change of magnetic flux in primary coil, if you are going to get an induced EMF in secondary coil, this kind of induction is called as mutual induction. Write that. Leave some space and write. Mutual induction is when there is an induced EMF in the secondary coil, when there is an induced EMF in secondary coil, induced EMF in secondary coil due to the change of magnetic flux in the primary coil. If you see deeply, you will understand that mutual induction is a consequence of self-induction only. It means whenever there is a mutual induction taking place, self-induction is also taking place, isn't it? Self plus mutual, only self. Can we have mutual induction without self-induction? Impossible. Because we want a coil for creating mutual induction, and that coil there will be a self-induction also. So, it is impossible to have mutual induction without self-induction. I hope you get my point. Okay. Now, coming back, please pay attention, mathematical part of it, please pay attention. You should realize that how much flux is produced in the coil is directly depending upon the current in the coil, because B is equal to mu naught Ni, I depends upon magnetic field, and phi is equal to Ba cos theta. So, how much is the magnetic field depends the flux. So, can I say that flux depends upon current? If I remove this proportionality, I have to add a constant, and that constant is called as L, which is called as self inductance. It is called as self inductance, also called as coefficient of self induction. From here you will see I can write L is equal to phi by I. Can I write? Phi is in Webers, I is in amperes. Weber per ampere is a unit of self inductance, which is also called as Henry. H is called as Henry. I will repeat. Weber per ampere is also called as Henry H. Not over yet. We know that induced EMF E is equal to minus d phi by dt by Lenz's law and Faraday's law. So, I can write E is equal to minus d by dt of what is phi? Li, L into I, L is a constant. So, E will become equal to minus L into di by dt. From here you can write the value of L, which will become equal to minus E into di by dt. And from here we get the definition of self-inductance. What is that? Self-inductance is defined as opposing EMF per unit rate of change of current. You may say, sir, I can also define self-inductance as flux per unit current. They won't give marks for that. It's true, but they are expecting you to define self-inductance as opposing, minus means opposing EMF per unit rate of change of current. So, whenever they ask you define self-inductance, you should define self-inductance is defined as opposing EMF per unit rate of change of current. If you have understood this, copy it fast. Shall I proceed? Shall I proceed? If you have copied this concept of self-induction, I will be able to throw some light on mutual induction also. Shall I? Please pay attention. I erased his copy. Sorry, Manishant. Okay, please pay attention. Here, can I say that flux in the secondary coil is proportional to current in the primary coil? Obviously, flux in primary coil also is proportional to current in primary coil. But we are talking about mutual induction now, that is induction in the secondary coil. So, flux in secondary coil will depend upon current in primary coil. If you remove proportionality, you have to add a constant, and that constant is called as mutual inductance. Also called as what? Coefficient of mutual induction. So, you can write from here M is equal to what by what? Phi S by IP. Once again, Weber by ampere called as Henry. So, whether it is self inductance or it is mutual inductance, unit is same, Henry. Couple of times in the board examination, they have given the question as what is the unit of self inductance or mutual inductance. Answer is Henry. Don't expect the question to come once again in your time. Okay? But anyhow, you should know that. We also know that EMF produced in secondary coil will become minus d phi s by dt. So, ES will become equal to minus d by dt of phi s. What is phi s? MIP. So, from here I will get ES is equal to minus M comes outside dIP by dt. So, what will be M? Minus ES by dIP by dt. So, how do you define mutual inductance? Opposing EMF in secondary coil per unit rate of change of current in primary coil, isn't it? Self inductance is defined as opposing EMF per unit rate of change of current, but mutual inductance is defined as opposing EMF in secondary coil per unit rate of change of current in primary coil. If it is clear, copy it fast. Let me know if you are done fast. Can I proceed further? Can I proceed further? So, now you came to know that self inductance L is equal to phi by I, or L is equal to minus E by di by dt, M is equal to phi S by IP, or M is equal to minus ES by dIP by dt. That is, self inductance is defined as opposing EMF per unit rate of change of current, and mutual inductance is defined as opposing EMF in secondary coil per unit rate of change of current in primary coil. Both have same unit, which is Henry. If they ask you a very basic question, but if they ask you what are the factors on which mutual induction depends, then you can current in primary coil, obviously yes. Loudly, that is same only, no here. It depends upon this. This is not like that. No. Next will be how these two coils are linked. Suppose I am giving 3 examples to you. One example is one primary coil is here, secondary coil is here. Second example is primary coil is here, secondary coil is here. Which will have more linkage, this or this? If I am having third condition, primary coil like this, secondary coil like this, which will have more linkage? So, primary coil and secondary coil, how their orientation is, that also determines how much mutual induction is taking place. But now I think you are understanding the meaning of mutual induction and meaning of self induction. Self induction means induced EMF will be in the same coil where change of current or change of magnetic field is there. And mutual induction is induced EMF will be in the secondary coil and change of current will be in the primary coil. If yes, then give the heading of the next topic, which is self inductance of a long solenoid. This question comes in derivation. Self inductance of long solenoid. Yes.
The previous we had the ES or E numericals in the formula. What will be the expansion? Which formula will be using for E EMF? Will it be BVL or it will be?
BVL is only for motional EMF, Thambi.
For this,
For this, you are finding the value of induced EMF. You have to differentiate the flux and get the value of induced EMF. Or else they will give you the value of induced EMF in secondary coil.
then distance, it depends upon distance between them.
Orientation, it depends. Not the induced EMF, the mutual inductance, it depends. Are you getting a point? Okay. Coming to this. Turn off itself. Without remote, I have to put it down. Okay? Yes. 10 minutes only remaining. We let it be off for some time. Guys, please come back. So now what you're going to do, we are going to take a solenoid and connect it to source of battery EMF, because we want current and a changing current obviously, and we are going to find this solenoid, what is the value of its L, that is self inductance. We are assuming its area of cross section is A, we are assuming its length as L. Please pay attention, this derivation is very, very important and very simple also. If you understand it now itself, no need of studying it next time, if you're getting the concept very clear. So, if you wonder why they have used the word long, why not just solenoid? See, this is also a solenoid, right? Coil, solenoid only. But this will not have B is equal to mu naught Ni. You know why? Loudly? Only one. No, if I take 2 turns also, no problem. Problem is, here the length of solenoid is smaller than its area of cross section. Always for a long solenoid, the length of the solenoid should be what? Much more than its area of cross section. Then only it will show the magnetic field value as mu naught Ni. Okay? So, if you want to make a coil behave as a solenoid, you should make its length bigger than its area of cross section. I hope you are getting my point. Diameter you can compare, diameter and the length. L should be much more than the diameter. Coming back. So, in this case, the moment I turn on the key, the current flows, and the moment current flows, there will be some magnetic field produced inside the solenoid? I'll give time for writing. Please pay attention and learn the concept now. So magnetic field inside the solenoid will be how much? Mu naught N I. I hope you know what is the value of N. What is N here? N is number of turns per unit length. Okay. So what is the value of flux going to be? That is, flux is what? Magnetic flux linked will be how much? Flux formula is what here? BA cos theta. For one turn, BA cos theta. How many turns do you have? N turns. So I am writing for N turns. For N turns, it will be N B A cos theta. What is theta here? Angle between magnetic field and area, parallel, 0 degree. So NBA I can write. So it will become equal to NBA. What is the value of B? N into what is B? Mu naught N I into, do you agree with me? Nothing I am doing. Just putting the values of B into this equation. Also, before some time we have learnt phi is equal to Li for self-induction concept. So phi is also equal to N into mu naught Nia, and phi is also equal to Ni. What we will get from 1 and 2? From 1 and 2, we get Li is equal to mu naught N small n into I into A. I gets cancelled. I get the self-inductance value as mu naught into N into, instead of small n I am writing N by L, isn't it? Into A. Do you agree with me? So this is the value of self-inductance of a long solenoid. The value is mu naught N square A by L. If somebody says, I want to write the answer in terms of number of units per unit length and not number of turns. Yeah, you can write, because we know that N is equal to N into L, right? So I can write mu naught into N square L square A by L. L gets cancelled. So some book, if you are reading, L is equal to mu naught N square A into L, it means they are taking N as number of turns per unit length. Otherwise, mu naught N square A by L, then N will be the number of turns. Don't confuse. If you are getting confused, don't read this. Just remember this. So what is the self-inductance of a long solenoid? Mu naught N square A by L, where N is number of turns. If in any context you are seeing mu naught N square A into L, there N is number of turns per unit length. If it is clear to you, copy it fast before I go to the official last topic, which is mutual inductance of two long solenoid. That is little complicated. Make it fast, please. Is it audible now?
Yes, sir.
Yeah. So now what I'm going to do, I am going to take two solenoids. One solenoid will have source of current. Another solenoid will have just the linking, and we just don't have anything. We may have a galvanometer if you want to check the presence of current. So what I'm going to do, I am going to on the key, current will flow in the coil, current will change from 0 to maximum, magnetic field will change from 0 to maximum, magnetic flux will change from 0 to maximum, and there will be an induced EMF in the secondary coil. When I turn off the current, then there will be a change in current from maximum to 0, the magnetic field will change from maximum to 0, the magnetic flux will change from maximum to 0, and there will be an induced EMF. Right? I hope you are understanding my point. I am bothered only about the induced EMF in secondary coil, because primary also will have. Since I have a coil, I will have self induction also, but we are going to talk only about the mutual induction here. Okay. So first of all, let me assume that current flowing in the coil is I. Okay. And let me assume that number of turns for the primary coil, number of turns in primary coil I am taking it as NP, and number of turns in secondary coil I am taking it as NS. So what is NP? Sir, I was searching for remote for a long time. Okay. You took this remote also? Asked.
Actually, he used this remote for that AC. That's why it didn't work.
Okay. So that room AC not work, this room AC also. Okay, fine. Let me continue. Sorry. Yeah, guys, coming back. Please pay attention. 5 minutes, I'll finish it. So number of turns in primary coil I am taking as NP. Yogit. And number of turns in secondary coil I am taking as NS. I am taking the length as L and area of cross section as A for both. You may have a doubt that what if area is not same? What if length is not same? We will always take the common length and the common area. Are you getting a point? If you have induction like this, another coil like this. So what is the common area of cross section? That only we will take. Or what if one coil is like this, another coil is like this? We will take the common length alone. Are you getting my point? So common length and common area. In this case, I am assuming both coils have same area of cross section and both coils have same length. Okay. Now what I am going to find first? First I am going to find what is the magnetic field due to current in primary coil. Tell me the value. Mu naught n small n, I should say NP, right, into I. Do you agree with me? Any problem in this? Okay. What is the total flux, or I should say magnetic flux, right? Total flux. What is the magnetic flux linked to secondary coil? What is the formula? NBA cos theta, isn't it? Now N here will be number of turns in secondary coil, am I right? Into magnetic field produced by the primary coil into area of, both are same only, A, into cos 0, so it will be 1, no problem in that. So I am going to get total flux phi is equal to NS BP, which is equal to how much? It is known to us, the value of BP is known to us. How much is that? What is this? What is the value of BP? Mu naught NP into I. Do you agree with me? Or if you want to write the current in primary as IP, if you want to write like that, it will be IP, nothing wrong in that. If you see, no, don't confuse. Because current flowing in primary coil, I can write IP if you want to write, no problem in that. Now also we know that, and this is the flux in which coil? Secondary coil, isn't it? So phi s I am writing. Also we know that phi s is equal to MIP. Yes or no? Just now we learnt. In the previous page to previous page, if you go, we have learnt, where we went? We have learnt, where we learnt? Phi s is equal to MIP, isn't it? Same thing I am using, phi s is equal to MIP. Equation number 2, equation number 1. What you get from 1 and 2? MIP is equal to NS into mu naught into NP by L I am writing into IP. IP gets cancelled. I am going to get M as mu naught NS NP. Yes, Tambi.
Area you left.
Yeah, thank you, man. Area I left here. It's I left area. Power area. Area here. One more area will come here. Yes. So mu naught NS NP A by L. What is that? Mutual inductance. If somebody wants to write in the form of number of turns per unit length, they can write, no problem in that. It will become NS into L. This will become NP into L divided by L. L gets cancelled. You will get mu naught NS NP L A. This is also correct. But I always prefer this one. I don't know why I like that. So if it is self inductance of long solenoid, mu naught N square A by L. If it is mutual inductance of two long solenoids, mu naught NS NP A by L. Where NS is number of turns in secondary coil, NP is number of turns in primary coil. If somewhere you are seeing this formula, here NS NP will be number of turns per unit length and not number of turns alone. This derivation is also important for the board examination. Question comes from here directly to derive this. Okay. So expect in school exam the question will come where they will ask to derive this expression. So with this we come to the end of this chapter. We will start AC in the next class. After copying you can drop online students, and after copying from here you can start leaving. So the girls will leave first and the boys will go next, or 3 are only there. You can go in your order. Go in your order, but don't block the way.